Here we're asked to solve a logarithmic equation. Let's begin by applying the product rule for logarithms. In other words, let's replace this sum with log base 2 of the product of these arguments, x times x minus 1, and that'll be equal to 1. Now at this point we can then apply the definition. So 2 to the 1 power has to equal this argument x times x minus 1. In other words, 2 equals x squared minus x. Now at this point we have a quadratic equation which we can obtain standard form if we subtract 2 on both sides, and that'll leave us with 0 equals x squared minus x minus 2. And at this point we can see the quadratic expression on the right side here factors. So x squared factors as x times x, 2 factors as 1 times 2, and 1 and 2 add up to negative 1 if the 2 is negative and the 1 is positive. Positive 1 times negative 2 is negative 2, and this is factored correctly. Now at this point we set each factor equal to 0, so x plus 1 equals 0, or x minus 2 equals 0, and that gives us two possible solutions, x equals negative 1 or x equals 2. Now remember, applying the definition like this introduces the possibility for extraneous solutions. So we need to check our answers. Now when I substitute x equals negative 1 into the original, we have log base 2 of negative 1 plus, at this point I'm going to stop, because I know log of a negative number is undefined. And that tells me x equals negative 1 is extraneous. Next, let's check x equals 2 and substitute that into the original equation. Doing so, we have log base 2 of 2 plus log base 2 of 2 minus 1, which is 1, and we need to see if that equals 1. Well, log base 2 of 2 is 1, plus log base 2 of 1 is 0, and certainly that does equal 1. That tells me that x equals 2 is the only solution to this original logarithmic equation.